Over a decade ago, farmed shrimp overtook wild-caught, such that by 2016, two-thirds of global shrimp production was farmed. The main potential food safety hazards of shrimp farming are infectious disease, chemical contamination, and veterinary drug residues. In terms of mercury, shrimp is the second leading source, but is still far behind tuna. In terms of banned pesticides, flame retardants, and polycyclic aromatic hydrocarbons, there are some significant concerns regarding human health risks associated with shrimp consumption. Safety limits were exceeded for banned pesticides chlordane, DDT, heptachloraldrin, dieldrin, and endosulfan. Now, this was based on worst-case scenario values, but on the other hand, based on just eating 3.5 grams of shrimp a day, which is like a single shrimp, or one serving of shrimp every 2 weeks or so. Eating just one shrimp could give you as much as 50 times more DDT than is considered safe, same with flame retardant chemicals, and same with naphthalene and benzopyrene. For PFAS forever chemicals, eating the highest levels of the most contaminated shrimp could pose a health risk, which comes out to be about a serving a day. Shrimp can also be a substantial source of carcinogenic heterocyclic amines, which is typically seen in dry heat-cooked chicken, like baked, grilled, fried, or broiled. Levels for shrimp were in the 10 to 50 range, which is what you start to see with chicken grilled at over 400 degrees Fahrenheit. Note that steaming, or presumably boiling, or other moist cooking methods are the safest ways to cook meat. Another issue with shrimp is foodborne illness, even with pre-cooked, ready-to-eat shrimp, which have been found to be an international vehicle of antibiotic-resistant bacteria. As shrimp farming has gotten more intensive, there's an increased occurrence of disease problems as a direct result of the higher stocking densities at shrimp farms, causing stress-initiated disease and then rapid transmission of infectious diseases. And along with more disease comes more use of antibiotics and disinfectant chemicals to keep the animals from dying prematurely. In India, where most of the shrimp eaten in the United States comes from, 90% of the bacteria tested were resistant to 3 or more classes of antibiotics. Thus, shrimp can serve as delivery vehicles of antimicrobial resistance to pathogenic bacteria to consumers and from country to country. 13 brands of ready-to-eat shrimp from 4 countries of origin were obtained from local grocery stores in the U.S., and 80% of the bacterial species picked up were antibiotic-resistant, and that included numerous resistant human pathogens such as E. coli and Salmonella. Foodborne pathogens were found in every single sample tested, and most of those contained multiple pathogens. Ready-to-eat shrimp are sold with instructions to just thaw before serving, which may result in consumer exposure to antibiotic-resistant bacteria. Enterococci are used as markers of fecal contamination of food products. At a retail level, about 85% of ground beef and turkey are contaminated with fecal bacteria, about half of chicken and a third of pork. Sampling more than 700 shrimp at grocery outlets in 8 states across the United States, researchers found that approximately 2/3 of the shrimp samples were contaminated with fecal bacteria. In terms of antimicrobial resistance in U.S. retail seafood, shrimp had the highest odds of being contaminated, and the risk was about twice as high in farm-raised shrimp compared to wild-caught shrimp. A small percentage were even resistant to a carbapenem antibiotic, which is considered an antibiotic of last resort. In the hospital, we used to call it gorillacillin. It's also been found in Canadian shrimp, linked to a farming operation in India, our #1 source of shrimp imports, and others traced back to Vietnam and Ecuador, other major shrimp importers into the United States. So shrimp farms may be a key reservoir of antibiotic resistance genes, which may pose a significant threat to public health. When we consume shrimp, we may also be consuming those antibiotic resistance genes, which can be passed along to human pathogens in our own body. Resistance genes have been detected in shrimp products destined for human consumption, but what about the antibiotics themselves? Are there residues of antibiotic drugs left in shrimp at a retail level? That's what I'll cover next.